Let's take a look at solving system of inequalities by graphing. We're going to review graphing inequalities, and then we're going to use the graphing method to solve systems of inequalities. So generally, to graph an inequality, you want to first draw the graph of the equation, and if it's a greater than or less than, you want to change the line to a dotted line. And then you want to identify the region that satisfies the inequality, and the way to do that is you shade that region. Now let's draw a graph of y equal to x plus 2. Generally, when you're drawing a graph, you have to focus on the x-intercept and the y-intercept. So we're going to treat it as if it's y equal to x plus 2. So our x-intercept, we have y equal to 0, so 0 equal to x plus 2, and then x equal to negative 2. So we have at this point x equal to negative 2, and our y-intercept, we have x equal to 0, so y equal to 0 plus 2, which is equal to 2. So we have this as our y-intercept. The next thing we're going to do is to draw a line that joins both together. So we got a line that joins those points together. So that is our line. And because it is greater than and it's not equal to, what we're going to do now is we're going to make it a dotted line. So we erase that portion of it to show that it's not equal to. And then the next thing we want to do is, if it's greater than, generally for straight lines, above to the left hand side, or you can say above the line is greater than, below the line is less than. Another way to test this is we have the origin test. So what we're going to do is we're going to use the point 0, 0 and plug it into the inequality. So we're saying y is 0, so 0 greater than 0 plus 2. 0 greater than 2 is false, so that means any part of the graph that has the origin is not considered a valid point. So we can see here that this right here represents the region that satisfies our inequality. So this is how you solve for a linear inequality. Now we're going to try the same for a quadratic inequality. So we're going to try y is less than x squared minus 4x minus 12. So we have two things to worry about. We have the x-intercept, y equal to 0. So we have x squared minus 4x minus 12 equal to 0. So you factor this and you have x minus 6, x plus 2. So x minus 6 equal to 0, which implies that x equal to 6. X plus 2 equal to 0, which implies that x equal to negative 2. And then let's look at the x-intercept. We have y equal to 0 minus 0 minus 12, which is negative 12. So this graph probably will not fit it, so we'll try to figure a way to make it work. X equal to negative 2, so we got that point right here. We have x equal to positive 6, we have that point right here. So ideally what's going to end up happening, I'm going to just put negative 12 right about here. So we'll extend our line right here. So our graph is going to look like this. We're going to join the points together. Okay, erase this portion right here. And then we're going to start from here, right about here. This is our graph here. And because it's less than, it's not equal to, we're going to make it broken lines to show that it's not equal to. Okay. Now, we're going to use the origin test. Let's look at the origin test. So the origin test, we use the point 0, 0 as a test point. So y is less than x squared minus 4x minus 12. So 0 less than 0 squared minus 4 times 0 minus 12. So 0 less than minus 12. This is factually inaccurate. So any part of the graph where the origin sits will not be a region that satisfies the inequality. So this right here shows the region that satisfies the inequality. So that's what we do to graph inequalities. Now, to solve a system of inequalities using the graphing method, we're going to graph the inequalities, and the solution set is going to be the shaded portion that satisfies both inequalities. So in this case, what I'm going to be doing is, when I graph the inequalities, I'm going to shade with two different colors so we can see a point of intersection. So let's take care of this. Y is greater than negative 5x plus 3, y is greater than 2. First, we're going to draw the graph of y is greater than minus 5x plus 3. So let's start with that. Y greater than minus 5x plus 3. We'll do that on this side, and then y greater than 2. That should be pretty simple. So we start with, assume that y equal to negative 5x plus 3, and we look for the x-intercept, which means y equal to 0. So 0 equal to negative 5x plus 3. So 5x equal to 3, x equal to 3 over 5. Then we look for the y-intercept, and at that point x equal to 0. So y equal to 0 plus 3, which is equal to 3. So y equal to 3, x is 3/5. So we're going to put it right about here. So we're going to draw a line, and the line joins both points together. So now, ideally, the region that satisfies this, because it's greater than, is always going to go above the line, and less than is going to go below the line. But let's try the point 0, 0 for the origin test. Okay, so what we're saying here is 0 is greater than equal to 0 plus 3. So 0 is greater than equal to 3, which is factually inaccurate. So what we're going to do now is we're going to shade every part of the graph that does not have the point 0, 0. So that's going to be this portion of the graph. This does not have the point 0, 0. The next thing we have is y is greater than 2. So y is greater than 2. So let's look at y. Okay. And because it's greater than, we're going to make it a broken line. And then the next thing we're going to do is we're going to shade the part of the graph that is above 2, because it's greater than 2. So we're going to shade the part of the graph that is above 2. So we'll look right here. This is the part of the graph that is above 2. So the best way to look at the solution set right here is to find where you have a cross match. So the area where you have a cross match is going to be the area that satisfies the inequality. So you can see that your cross match is right around where you have the brown and red lines crossing, creating a cross match. That's where you have the solution set for this inequality. Next, we have these equations here. We have y greater than x minus 3. So we always start with y equal to x minus 3. And then on this side, we have y equal to negative x minus 1. So we look for the x-intercept, y equal to 0. So at the x-intercept, y equal to 0, that means that 0 is x minus 3. So x equal to 3. At the y-intercept, x equal to 0. So y equal to 0 minus 3, which is minus 3. So for this line, we have x equal to 3 and y equal to negative 3. So let's draw a line for that graph. Okay. Next thing we're going to do here is we're going to find the region that satisfies this inequality. Because it's greater than equal to, we don't have to create dotted lines, we have solid lines. But above the line is going to be greater than equal to, so we can start with the 0, 0 origin test. So origin test here shows that 0 should be greater than 0 minus 3, 0 greater than negative 3. So every part of the graph above the line where you have the region 0, 0 or the origin is considered a valid point for a valid region for that inequality. So we start with the second equation. So look at the x-intercept, y equal to 0. So 0 equal to negative x minus 1. So negative x equal to 1. So x equal to negative 1. Okay. And then y-intercept, we have x equal to 0. So y equal to 0 minus 1, which is negative 1. So we're going to use the different color for this. So x equal to negative 1. Y is also equal to negative 1. And then we're going to draw a line that passes through both points. Okay. So now we need to find the region that satisfies that inequality. So we're going to use the origin test again. Origin test. So we're saying 0 is greater than equal to 0 minus 1. So 0 is greater than equal to minus 1. So as usual, because it's greater than equal to, it's above the line. So we're going to shade our portion above the line. It also has the origin. So we have this region right here is the region that satisfies the second inequality. And we have a region that satisfies both inequalities where you have a cross match of both regions. So that's about right here. Right here. That's your region right there. So now we're going to move over to quadratic inequalities and we're going to graph them. So let's start with x squared y. We're going to first make it equal to x squared plus 2x minus 3. So we look at x-intercept, y equal to 0. So 0 equal to x squared plus 2x minus 3. So we have x, we're going to factor this. We have x plus 3, x minus 1 equal to 0. So x equal to negative 3, x equal to 1. And then the y-intercept, x equal to 0. So we have y equal to 0 plus 0 minus 3. So y equal to negative 3. So we have y equal to negative 3. And then we have x equal to negative 3 and x equal to positive 1. So what we're going to do now is we're going to join these points together to create a quadratic. So let's and do this right here. So now we're going to look for the origin test. Because it's less than equal to, we don't need to create broken lines. So the origin test, we have the point 0, 0. So we have 0 is less than equal to negative 3, which is false. So any part of the graph that contains the origin is considered an invalid portion, is incorrect. So we've shaded the opposing parts right there. And then this also. Now let's look at the second. We look at the second in quadratic. So we have y equal to x squared minus 4x minus 5. So x-intercept, we have y equal to 0. So x squared minus 4x minus 5 equal to 0. So we have x minus 5, x plus 1 equal to 0. So x is 5 minus 1. And y-intercept, x equal to 0. So we have y equal to minus 5. So let's go ahead and draw the graph here. We have y equal to negative 5 right about here. We have x equal to 5 right about here, and x equal to 1 right about here. So we have a situation. Let's draw this graph right here. Right here and right about there. Okay, so now we're going to use the origin test. And with our origin test, we use the point 0, 0. So 0 is less than equal to negative 5. This is inaccurate. So any part with the origin is completely inaccurate. So let's look at that to find the portions that satisfy both inequalities. So you can see right here, so there's an overlap right about here. See, right there. That's where your overlap is. So that is the region that satisfies both inequalities. Finally, we have this example. We start with y equal to x squared minus 3x plus 2. We look for x-intercept, and there y equal to 0. So we have x squared minus 3x plus 2 equal to 0. Factor this out. We have x minus 2, x minus 1 equal to 0. So x equal to 2 or positive 1. And y-intercept, we got x equal to 0. So we have y equal to positive 2. So let's put this on the graph. We have x equal to 2. X is also equal to 1. And then y equal to 2. So what we have here is we have a graph that looks like this. So, and then we use our origin test. So we use the point 0, 0 to see if 0 is greater than 2, which is false. So what we're going to have is we're going to have every part of the graph that has the origin does not work, so it's going to be inside of the graph. Now let's try the second one. We got y equal to x squared minus 6x plus 8. At the x-intercept, y equal to 0. So x squared minus 6x plus 8 equal to 0. So we got x minus 4, x minus 2 equal to 0. So x equal to 4 and also 2. Now let's look at y-intercept. Y-intercept, we have x equal to 0. So y equal to 8. Now we're going to try to put this on the graph. We have x equal to 2, okay, right here, x equal to 4 right here, and x also, and y equal to 8. So we have, okay, that's a rough sketch of what the graph looks like. And then we're going to use the origin test. We'll put the point 0, 0. So we're saying 0 is less than equal to 8, which is true. And so any part of the graph that has the origin is going to be valid. So what we now have, so the region where you have the blue and the brown intersect is the region that satisfies this inequality.